Hi everyone, this is Thiagarajan, retired Deputy Chief Engineer from Indian Railways. So, in this video, let's see about the vertical curves on railway tracks in Indian Railways. Okay, in the earlier videos, I had been explaining something about the curve, that means in the horizontal plane. So, that used to introduce, wherever there is a change of direction takes place, and we used to introduce the horizontal curve that we have seen in detail. So, in this video, we are going to see the vertical curve. That means the curve which are provided in a vertical plane. So that normally it will take place wherever there is a change of gradient takes place. Okay, that means this falling to rising or rising to falling. In those situations, and we need to provide a curve in a vertical plane for smooth negotiation at the junction points. Okay. So, and also this video I would like to discuss something about the longitudinal track profiling also. Okay, so normally whenever there is a undulation in a longitudinal plane, in the vertical plane, and we need to correct those the undulations to ensure the smooth level, longitudinal level. So for that we have some application. Even myself I have my website. In my website, I have my application that is for correction of the longitudinal level. Okay, so that also we will see in detail, and that application also to some extent will take care of providing a vertical curve also. Okay, let's go to the subject. So in our scenario, the vertical curves are the curves which are provided in a vertical plane. Okay, it is provided in railway track as well as in a highways and the roads also. Okay, for smooth negotiation at the point where there is a change of gradient takes place. Okay, coming to the types of vertical curves, we have two types. One is summit, other one is sag. What is sag? When any up gradient is followed by a down gradient, that will form sag or valley. This location used to say sag point. And similarly, when in a down gradient, followed by up gradient, that will form a summit. It's peak, peak location. It will form a summit. And both the locations, we need to provide a vertical curve, because there is a sudden change of direction in vertical plane takes place. Okay, in both locations, sudden change of gradient takes place. So because of that, this location has to be properly eased out. If it is not being properly managed, what will happen when the trains are negotiating through this connection? There will be discomfort to the passenger. At the same time, in extreme case, it may result to some unsafe condition also. Okay. Further, Indian Railway Permit Manual prescribe when the vertical curve has to be introduced, in which situation, and also what is the minimum radius of the curve you have to provide for various group of routes. Okay, that is also available in PG. Okay. And this in general, this will be a situation, up gradient, down gradient. Okay, it will follow, and down gradient sometimes will followed by up gradient. But many times this also will happen. That means there will be a steep up gradient followed by a flat up gradient, and the flat down gradient, flat down gradient followed by a steep down gradient. So both the cases, it will form sag. And also these other situation also will come, that steep down gradient followed by a flat down gradient, and flat up gradient followed by a steep up gradient. In both the cases, these cases, it will form summit. Okay, so the all situation, we need to provide a vertical curve. Okay, when the limit of the change of direction, change of gradient, okay, it's exceeding certain limit. Okay, so we are supposed to provide for ensuring the smooth negotiation of the vehicle through these connections. Okay, this is about the types of vertical curves. Okay, so and also I want to say normally we used to give the sign, negative sign for the down gradient and positive sign for the up gradient. Okay, so like this. But in this case, suppose here also here we give both are up gradient. Here it is steep, it is flat. That is why, but both are up gradient. That's why we are giving positive sign, even though it is having vertical curve in between. Change of direction is there. And similarly here also is also down gradient, is also down gradient, but it is a steep. This is a somewhat flat. So here we are giving negative sign. Okay, so like that we are giving the sign according to the gradient. Whether up gradient means we are giving positive sign, when it is down gradient we are giving the negative sign. Okay, this is a way we used to follow. This is required for the purpose of design, that we will see later while doing the example, no, while doing the design. Okay, that we will see in what way it is helping. Okay, centrifugal force on vertical curves. So naturally there will be centrifugal force which will be acting on the vehicle while the vehicle is negotiating a sag point or a summit point. So in case of sag, when vehicle traveling, in the down gradient to up gradient, passing over the sag, so when the curvature is very sharp, there will be more centrifugal force which will be acting on the body. So always the centrifugal force which will be acting away from the center of this curve. So because of there will be more on-loading effect will be there. The on-loading effect will cause the more load exertion of vehicle to the rail, and also there will be more force on the axle as well the springs of the vehicle. So which will result to a failure. Apart from that, there will be a discomfortness also, because because of vertical acceleration which will be acting downward here. So there will be a discomfort factor also if sufficient curvature of radius is not provided. At the same time, when it is passing over the summit point from gradient to down gradient, here the centrifugal force acting away from the center, that will be upward. So because of the upward action of centrifugal force, there will be offloading effect, more offloading effect will be there. So the offloading effect will cause the loss of contact of wheel, and sometime in case of any curvature, curved track alignment, curved alignment which is joining with the vertical curve, the summit point, the condition will be further worsened. It may result to some derailment if sufficient radius of curvature is not provided. So that is why we are supposed to take care of these two locations, sag point, summit point, and the location should be properly eased out by providing a vertical curve of prescribed radius. As far as Indian Railway permanent way manual concerned, it stipulates how much radius of curve should be ensured at the sag point, summit point for various roads in broad gauge, on meter gauge. So we are supposed to follow that. So while execution of your the construction or forming embankment, necessary curvature you must ensure in the vertical profile. So in detail, if you want to see the particular location, that is sag, and safety concerns as already discussed, there will be more on-loading effect will be there. That will be acting downward centrifugal force, so increasing the load on springs and axles. And also the brakes are applied. See, for example, sometime what will happen while the vehicle train is passing over the sag point, some portion of vehicle will be in a up gradient, some portion of vehicle will be down gradient. In the up gradient, when it is climbing over that, sometimes there will be a struggle of climbing over some good strain and all, or some because of application of brake while it is moving on the up gradient. What will happen? The rear portion of vehicle which is in the down gradient, because of the gravity push, there are chances for the bunching of vehicle at the sag point. Because of the bunching effect, there will be a lifting of a vehicle. That means here also, apart from on-loading, here offloading will take place and result to some derailment. So this is something about the safety consideration as well as sag location is concerned. That is why we are supposed to ensure a proper curvature to overcome these issues. And also passenger discomfort point of view, because of the centrifugal acceleration which is acting downward, there will be discomfort of passengers when it is not properly, the location is not managed with sufficient provision of the vertical curve. Okay, and you can diagrammatically, explain here. You see here, this is a train, and it's just coming from the down gradient and passing over the this sag. This location, when it is coming, so there will be more momentum. Okay, so because of that, there will be a centrifugal force that will be acting downward here. Okay, there will be acting downward here. Because of this, there will be more force on the rail, etc. At the same time, these vehicles, compound also will be subjected to more force, the springs and axles also. So also there will be discomfortness because of the vertical acceleration, okay, the downward acceleration. So that is why it's to be properly controlled by provision of proper the flat vertical curve as prescribed. Okay. So at the same time, this is actually discussed. Some portion of vehicle is in the up gradient, some portion of vehicle in the down gradient. Suppose when the brake is applied here, or sometime it's just climbing issues there, and this portion of load will be acting downward. This because of the gravity push. So there will be bunching of vehicle will take place. Because of there will be the lifting of a wheel up, or that means because of the offloading effect, offloading effect, there are chance for the derailment. So this is to be taken care. Coming to the summit point, the safety consideration, safety point of view, see, as already discussed, it's offloading, because centrifugal force acts here upward. Okay, that because of that there will be offloading will take place, and it's coupled with some lateral force or due to curvature existing at the location, it results from derailment. Okay, and also another issue is that because of the tension in the coupling, as already discussed, 50% of train in a down gradient, 50% in the up gradient. What will happen? There will be tension development in the coupling. If it is excess, it results to some parting of vehicles, and thereby the unusual some occurrence will take place. Then of course there will be a discomfort of the passenger. Okay, at the summit point, the curvature is very sharp. Even practically would have experienced in your life and seen, watched some bike racing or car racing on ramp. They should do some adventure, racing on ramp. They will jump. So all because of because centrifugal force. Because whenever the movement takes place, it will try to go tangentially. Any body moves tangentially. So when the curvature is sharper, and because the tangential travel, and sometime there are chances for going out of path, so offloading. Okay. So, but in case of road vehicle, it's okay. But in the train vehicle, it is unsafe, because the vehicle has to follow the track exactly. Otherwise, there will be a mishap. So that is why we are supposed to ensure the proper curvature at the summit point. Okay. So here, this is a pictorial representation. See here, as already discussed, this is your train moving on a up gradient, passing your summit point, and because of that there will be always, centrifugal force acting out in center. Okay, there will be offloading effect will take place, and sometime, this wheel will have the loss of contact. That may result from derailment also if proper curvature is not there. Okay. At the same time, here, because of the inadequate curvature, 50% vehicle here, 50% this side, and here this coupling will undergo heavy tension, and because of that, if the tension is excessive, results of parting of vehicle. Parting of vehicle. Because of parting of, this front portion will go this way and the rear portion will go this way, and result to sometime results to major mishap. So all those things should be taken care, and proper vertical curve to be designed at these locations. Okay. So where in which situation we have to provide the vertical curve? So they have prescribed. The Indian Railway Permanent Manual prescribes when the vertical curve is needed. Okay. It's the algebraic difference between the two grades. Okay. If it is more than 0.4%, 4 mm per meter, we are supposed to provide the vertical curve. What is algebraic difference? You see here, this is 1 in 100 grade, this is 1 in 200 grade. We have to take the algebraic difference. Normally, the down gradient we have to put a sign of negative, minus, and up gradient we have to put a sign of plus, positive sign for the up gradient, rising gradient, and negative sign for the down gradient, that is falling gradient. So algebraic difference, we know with the sign we have to do the difference. It's called algebraic difference. Here it is minus. Suppose for example sag point, let us take this sag point. So here 1 in 100 minus difference minus 1 in 100, 200. This is positive. So minus 1 by 100 minus 1 by 200 equal to minus 3 by 200 equal to minus 15 by 100. Minus indicates sag. That means 15 mm per 1000 mm. Okay. But as far as our manual provision is there, we are supposed to provide the vertical curve when it is exceeding 4 mm per meter. Here it is 15 mm per meter. So necessarily this location you have to introduce a vertical curve. Similarly, if you coming to this point, here 1 in 200 up gradient, and here down gradient 1 in 150. That means see here plus because of up gradient, plus 1 by 200 minus of minus because it is a down gradient, minus of minus 1 in 1 by 150, that's 7 by 600. If you are converting, making denominator 1000, it will come around 11.67. That means 11.67 mm per meter. Okay. Plus sign indicates summit normally. Okay. So necessarily this location also we are supposed to provide the vertical curve. Okay. And so the location also is supposed to see that we should not allow the vertical curve. The unbalanced deck bridges, girder bridges and all. And points on crossing. Because points on crossing, there is a lot of connection will be there, discontinuity will be there. Vertical curve is there is chance for the lifting up of rail up, some discontinuity portion, some derailment. And also transition portion of the horizontal curve. So here also, because one base rail will be horizontal and the other rail only we are providing the easement, super elevation easing out, that will be grading curve. Because the level difference, that location also will be critical. We are not supposed to allow vertical curve. Okay, these locations. So then coming to the radius of vertical curve, you see, as far as possible, the vertical curve what we are providing in a sag or summit point should be sufficiently flat. Always the flatter curves will give the comfortness. It will reduce the discomfortness. Okay. And for that, we are supposed to reduce the vertical acceleration. So we have been discussing, in the previous videos about the acceleration and all. Whenever any vehicle or body negotiating curve, that will be subjected to the centrifugal force, centripetal force, and because of there will be acceleration. If it is negotiated in the horizontal plane, horizontal curve, there will be lateral acceleration. Okay, that is to be controlled. So when it is negotiating a vertical plane, that means in a vertical curve there will be vertical acceleration. So that is to be controlled. If it is excess vertical acceleration, will give the more discomfort to the passenger. So as far as possible, and in railways and so our vertical acceleration, what we have set is 0.3 to 0.45. That means it should not be more than 0.45 meter per second squared. Okay. So for this condition, how much radius, minimum radius we are supposed to provide, that is to be decided. Okay. So as discussed earlier, you know pretty well the acceleration equal to v squared by r. That is square of the speed divided by the radius of the curve. Okay, that will be our acceleration. This I have discussed earlier. Okay. So this equation we can find out for keeping this limiting acceleration of 0.45, and for that how much radius, the minimum radius we must need, we have to calculate. Okay. So we can rearrange the equation that AM, that is AM means what? This limiting acceleration equal to v squared divided by RE, that is maximum sectional speed of the train and radius of the vertical curve. So that is the case, RV is equal to v squared by AM. Then RV, whatever we get, that will be more than that, the whatever radius we are getting out of this equation. That is, RV should be greater than v squared by AM. Okay. So using the relation, we can find out the radius of the vertical, what is to be provided. Okay. So assuming then our sectional speed is 160 kmph. Okay. Yeah, as already discussed, our vertical acceleration and the limiting value is 0.45 meter per second squared. So substituting here, we can get the radius. So the radius should be equal to or more than the value what we are getting out of this equation. Okay. So substituting here this value, we are getting 4,389 meter actually. Okay. For 165 kmph and for this vertical acceleration, the permissible limiting value, we are getting the radius of vertical curve is equal to 4,389 meter. However, the Indian Railway Permanent Manual stipulates what should be the minimum radius of the vertical curve to be provided for various routes in MG. So as per para number 417 of IRPWM, Indian Railway Permanent Manual, for group A it is 4,000 meter, there is a minimum radius. Okay, for group E it is 3,000 meter, and other routes CD and all 2,500 meters. So to conclude, the whatever summit curve or sag, that should be taken care and properly it's to be contemplated and properly ensured during the initial construction of the forming embankment itself. However, during service, if in case of any variation, minor variation, that can be attended to by increasing the ballast cushion. So finally, what to want to say, it should be properly designed. The vertical curve is very, very important in safety and comfort point of view. Okay. Okay, let's see an example for designing of a vertical curve. Okay. So designing mean what? That we have to find out the levels of the vertical curve. So for setting out the curve, we want to know the levels of the points which are lying on the curve at a regular interval. If we know that levels, then we will be able to fix the level and we can form the vertical curve at the point where the change of gradient takes place, whether maybe whether it is summit or sag. Okay. So this example, this is about summit actually. Okay, that I read out the question. In group A route BG, rising gradient is 1 in 100 and which meets 1 in 200 gradient. The point of intersection, the chain age is 1000 and RL is 100. First they asked whether the vertical curve is required or not. Then if so, we have to provide the vertical curve. Okay. For that we have to find out the chain age and RLs of the points on the curve. Okay. So since this falling gradient is followed by rising gradient, that means it will form only summit. Okay. Yeah. So the available data they are given is chain age is 1000 at the intersection point and RL is 100. So with that we have to proceed. Okay. But of course now we are going to do mathematically using some trigonometry, and we are going to calculate the data which are required for setting out the curve. So of late, we have some modern methods. We have softwares available, special softwares available, and also even using AutoCAD also we can set out the curve. That means we can retrieve the data. We can get the data. Okay, that means for levels and chainage and all. That also possible. But even then, we must know the basics. See how it is to be done. So for the understanding purpose, that's why I have just taken this problem. I want to explain. Okay, we'll proceed further. Here, 1 into 100 rising gradient, then it changes to falling gradient of 1 into 100. The point where the change of gradient takes place, it's called intersection point. Okay, like horizontal curve, where there is change of direction takes place, that will be intersection point. Like that here, change of gradient takes place, that will be intersection point. The amount of the change of direction, change of gradient, that's called a deflection. That angle is deflection angle. So deflection angle equal to theta 1 by plus theta 2. That means 1 in 100, the gradient. That means the angle of inclination we are taking theta 1, and down gradient that we take as theta 2. So automatically this deflection total angle will be equal to theta 1 plus theta 2. Okay, if you take this, some horizontal line, this is parallel. This angle equal to this angle. Parallel, if you are putting, horizontal line. So this angle equal to this angle, and total angle theta 1 plus theta 2 equal to theta here. This is total deflection angle. Okay. And of course, chain age 100 and 1000 and RL is 100. Okay. Then first we have to find out the tangent points. First, because we want to introduce a curve, and we have to fix the point where we have to start the curve and where we have to end the curve. The two tangent points we have to first calculate. So for calculating what already we have discussed, in the horizontal curve. So tangent length equal to this tangent length equal to t equal to r tan theta by 2. Deflection angle divided by 2. Okay. So actually r normally for broad gauge, it has been prescribed how much the minimum radius you must provide for the broad gauge track. So with that we have to proceed. We have to first find out the tangent length. Then after setting that, from this tangent point, the tangent point 1, that is the beginning of a curve, from there we have to, so how much chainage, what chainage, how much level we have to keep for setting out the curve, that we have to calculate. Okay, we'll proceed. First, the question they asked, whether the vertical curve is required or not. First we have to find out. First we have to decide whether the curve is required or not. So as already discussed, the vertical curve is required whenever the algebraic difference between the two grades is equal to or more than 4 m per meter. We are supposed to provide the vertical curve. So we have to do here the algebraic difference between of two grades. The first gradient, and this means rising gradient, it is 1 in 100. The second gradient is falling gradient, that is 1 in 200. Here it is algebra difference. The algebra difference means we have to do the difference including the sign. Okay, that means normally, as I already discussed, we are giving the positive sign for the rising gradient and negative sign for the falling gradient. Okay, so with that we have to do the difference. So 1 in 100 rising gradient positive, then difference for difference minus, and minus of 1 by 200. That means since it is a falling gradient, we are giving the minus sign 1 by 200. So if we are summing up, we will be getting around some 3 by 200, and finally we are converting, the denominator to 1000, because 1 meter, 1000. So that we are getting 15 as a numerator. So 15 by 1000. So will be final, that algebraic difference. That we can say as 15 mm per meter. 15 mm per meter. But whereas our the limit is 4 mm per meter. Since it is more than 4 mm per meter as per Indian Railway permit manual, so we are supposed to provide the vertical curve. It's this location we need the provision of vertical curve. And also even the manual says that minimum radius is 4000 meter the minimum radius. Okay, para 417. Since it is not given, and we can take minimum. Even you can go for flatter also, but minimum is 4000. Then that is why we take 4000 meter the radius. And for fixing your tangent length, tangent point. See, we need to know the deflection angle. So deflection angle equal to theta 1 plus theta 2. So theta 1 equal to 1 by 100. We are keeping everything in a now radians. Suppose theta is equal to tan theta equal to 1 by 100. So theta is equal to tan inverse of 1 by 100. Suppose we want to get in degree, then we can do like this: theta equal to tan inverse of 1 by 100. Like that, tan theta equal to 1 by 200 and theta 2 equal to tan inverse of 1 by 200. But if you want to keep in radians, so theta 1 equal to 1 by 200, like the theta 2 is equal to 1 by here 200. Here it is 1 by 100, here 1 by 200. So theta deflection angle in radians equal to theta 1 plus theta 2. So in that way it has been written 1 by 100 plus 1 by 200 radians, then finally 15 by 1000 radians. Okay, this is our deflection angle. Then we are finding out the tangent length. I discussed or tan theta by 2, or if we are substituting in degree, if you want, we are putting in a radians, we can make r into theta by 2. So radius is to 4000 and the theta is equal to 15 by 1000 in radians and divided by 2. And finally the tangent length is equal to 30 meter. Okay. And also the deflection angle is very small, because you see, for this if you are working out, that degree will be less than deflection angle will be less than 1 degree, very meager. So that is why there won't be much difference. The tangent length and the chord length and arc length almost will be minimum. The difference will be minimum. So since the value of deflection angle is very small, we consider the length of a vertical curve, the arc length equal to chord length. Okay. So now we have to find out the chord length, so that we can for setting the levels of the points which are on the curve, and with reference to some level, and we have to fix the offset. Then we have to find out the orals, and and for that you must find out the chord length connecting the to tangent point. What is the length of chord? So here we are considering the arc length equal to chord length. That is why normally already we have discussed the arc length equal to r radius, r into theta. Theta means angle subtended at its center. As you all know, the deflection angle equal to angle subtended at center. That means the theta equal to this theta. So theta already we know it is 15 by 1000. So once you know the theta, so we can find out the arc length. So r theta equal to our arc length. So r is equal to our radius of the curvature to be provided for the vertical curve. Okay. So that we are taking as per the Indian Permanent, that we are taking as a 4000 meter, and of course theta we take in a radians. So r into theta will give you the arc length. So here we are getting equal to 60 meter. So length of arc equal to 60 meters. Since the deflection angle is very meager, so arc length equal to chord length. So chord length also will be 60 meter. We consider like that. Okay. This is so one step. Then second, this one, we have to find out the oral chainage of the tangent points, very important. Okay. So oral, of course, we can calculate, we have to come from this intersection point where they are given chainage and oral, that is 1000 meter chainage and oral is 100. So when you come this way, this the tangent length of 30 meter. So here 1000 meter chainage. So chainage at the tangent point 1 will be equal to 970 meters. So 1000 minus 30, 970. Similarly, we have to find out the oral of this point also. So here oral is 100 meter, and this point it is falling is 1 in 100. That means for 100 meter 1 meter fall. For 30 meter how much fall? There will be 30 by 100 will be there. So 0.3. So 100 minus 30 by 100 will be equal to 99.7 meter. So here oral is equal to 99.7 meter. Like that, we have to find out the chainage and oral of the tangent point 2 also. Okay. So from here we have to come this way, 1000 plus 30, 1030 will be our chainage here, and level will be equal to, here fall is 1 in 200. That means 200 1 meter fall. That means for 30 meter how much? It will be 0.15. That means 100 minus 30 by 200 equal to 99.85 meters. So now we got the chainage and oral of the tangent point 1 and 2 also. Okay, and subsequently we have to proceed to find out the orals of the points which are on the curve. Okay. Now what do you do further? Now you are connecting the chord. That length of the chord is equal to 60 meter. So we are dividing conveniently. Since 60 meter, we are dividing into 6 equal parts, 10 meter interval. Okay, or so that each part we take and with reference to this chord and how much offset we have to calculate, so that we will be able to get the oral of the points which are on the curve. Okay. Now, first we have to calculate the chainage. Chainage is how much? The chainage of this point A, at point A, it is 970 meter. Then 10 meter interval, no. So then M dash. Now each offset we are denoting like this: M dash, N dash, and B dash, and SS dash, and TD dash, and finally C is the tangent point 2. Here tangent point 1 you are taking as A point. Okay. So chainage at here, first point dash, that is 980, 970 plus 80, like that. Here 980, here next 990, and 1000, and 1010, 1020, and 1030. Okay. So we know the now chainage of the each point. Okay. Then we have to find out the oral of this point. So oral, for oral, and we have to find out the offset dash, Mn dash, Bb dash, SS dash, and T dash, and C. We have to find out the offset, and that we can calculate. Already we have discussed in the horizontal curve. The offset will be equal to versine. So if you take the mid offset, so Bb dash, mid ordinate equal to versine. So you know the formula for versine, that is equal to C squared by 8R. So using the relation we can find out the ordinate mid offset Bb dash. So here total length, chord length equal to 60 meter, and R we know that is 4000 we are our radius of the vertical curve we are setting. So C squared by 8R will be equal to 0.1125. Because C squared, 60 squared divided by 8 divided by 4000. So here already the ordinate Bb dash, and if you are finding the versine, this portion for 20 meter minus this portion will give you the this ordinate. So here I put like this. So let us take, this is L, it is missing here, it is L. Okay. So the BL will be equal to 20 squared divided by 8 divided by 4000. So calculating this, you will be able to get 0.1 meter. So this will be equal to 0.1 meter. And coming to this dash, again we take this chord. This chord how much? 10, 10, 10, 10, 40 meter. Okay. So 40 meter we are finding out the versine. This we can take K, this point let us take K. So BK will be equal to 40 squared divided by 8R, 8 into 4000. So total is 0.1125 minus this portion will give you the dash. So dash equal to, now we are getting, calculating this way, we are getting 0.0625. Okay. So N dash equal to SS dash and dash equal to T dash. So now we got the offsets, every offsets, BB dash we know, and N dash we have calculated, and dash, and similarly this is also SS dash, TT dash, everything we calculated. Then what we are doing now, we are drawing a datum line, because this is summit point, and we have to take a lower tangent point. No, there are two tangent points, A and C is there, tangent point 1 and 2. And whichever is lower we have to consider. So here with reference to these two tangent point, this is the lower, okay, 19.7, this is higher, 19.85. So lower point we are doing, and we have to reference this point, we have to draw a datum line. With reference to datum line, the how much difference is there for the each point to the cord, that cord connecting the cord, no, AC. So here for total 60 meter difference is how much? 0.15. Total length of cord is 60 meter. For 60 meter the level difference is 0.15. Okay, because 99.85 here, 99.7, the difference is 0.15. If that is the case, for each point how much rise is there, level difference is there, then we have to find out. With reference to the datum line and M dash, N dash, B dash, S dash, T dash, we have to find out the difference. So if that is the case, for 10 meter, no, for 60 meter, 0.15 means for that means for 1 meter how much? The 0.0025, 0.0025, 10 meter. For 60 meter, 0.15. For per meter, rise is equal to 0.0025, okay, meter. From there, for 10 meter, how much you can calculate? Okay. So this is our datum level 19.7, and plus we are finding out the RL at M dash, N dash, B dash, S dash, T dash. So this per meter, no, 0.0025 means per 10 meter how much? 99.725. And 99.7 is a datum level, plus 20 meter how much? 20 into 0.0025, 19.75, like that. For 99 points B dash, it is coming around 99.775, and for S dash RL comes to, for 40 meter 19.8, and for T dash it is 19.7 plus 50 into 0.0025, it's coming to 19.85. So now we got the RL of the points M dash, N dash, B dash, S dash, T dash. Of course we know the chainage. So now we have to find out the RL of the points which are on the curve. Okay, that means M, N, B, S, T. That location, no, that point RL we have to find out. Chainage we know. No. So A starting point 970, and M it is 980, N it is 990, B it is 1000, and S 1010, and T it is 1020, and last C, that is 0.2, that is 1030. And similarly we have to find out the R also. R of the M dash, N dash, B dash, S dash, T dash we know, plus MM dash also already calculated. M dash already calculated, 0.0625, and N dash equal to 0.1, and B dash equal to 0.1125, and SS dash same thing, 0.1, and TT dash equal to 0.625. So adding with the RL of the M dash, N dash, B dash, S dash, 99.725 plus this thing, 99.75 plus this thing, 99.75 plus this thing, and 99.8.1, 99.825 plus this thing, we are getting the RL of the points which are on the curve. that is for point M it is 19.785 and N 19.85 and B 19.8875 and S 19.999 and T 19.8875 and finally of course the connecting point 99.85 will be your oral of our point C, that is tangent point 2. Okay. So once you know the orals, we will be able to set the level and fix the curvature. So this is the way so we are calculating. Okay. Only just mathematical and some trigonometry is there, then once you know you will be able to do the job. Okay. Okay, the previous exercise we have seen, it is. So generally, sometime, there will be a down gradient followed by up gradient or up gradient followed by a down gradient. In those cases, we used to do like that. But in some cases, sometime, as already discussed, there will be a steep down gradient followed by a flat down gradient or flat up gradient, followed by a steep up gradient. In those cases, how to do it? Okay. First case, we will take a summit type. That means steep gradient followed by down gradient and flat up gradient followed by a steep up gradient. These cases we will see. We are not going to completely work out the example, but anyway, this important thing is you should note down how to do the algebraic difference and how to find out deflection angle. Just trigonometrically, according to the situation, you have to apply your mind and do it. Here, see, as I told you, in case of downgrade, this is also downgraded, this is also downgraded. So downgrade, you have to give the sign of negative only. So here, this case, is up gradient, here also up gradient, but it is steeper, it is somewhat flatter, less steeper. Okay. So order maybe, but it is a up gradient. That is why we are giving the positive sign. Positive sign. Here it is missing, it is positive sign. Okay. Anyway, algebra definition, what I already discussed, the including sign, we have to do the difference. That's all. Here, holding 400, we have taken minus 1 by 400. Here also, minus of, 1 by 400, the difference we are putting minus. So when we are doing it, we will get now 3 by 400 and making the denominator 1000, we are making, numerator 7.5. Then 7.5 per meter. Okay. This case also, we need to provide vertical curve. And coming to the deflection, earlier case, we used to put theta equal to theta 1 plus theta 2. But here we should see, this is a line coming, this is the other line deflecting it. And theta equal to theta, deflection angle equal to theta 2 minus theta 1. Okay. Theta is it is a sharper, the steeper gradient minus the angle of a flatter gradient normally. Okay. In this case will come. How come? You can just work it out, So parallel, full angle is theta, full angle theta 2 minus this angle will give you the theta. Okay. That's what made. So if we are doing it, almost we will get the same, this thing value will come, that 1 by 100 minus 1 by 400 in radians, then 7.5 divided by 1000 will come. Okay, this is the way you have to do it. Like that here also, up gradient, then flat up gradient is going. So in this case, we are direction, based on direction only we are doing it. This is a direction here, this is a direction here. So climbing steep up gradient, then goes to flat up gradient. So here difference, here also up gradient we are giving the positive sign. So 1 by 100 positive and difference minus, then positive 1 by 400. That's all. We will get 3 by 400 and 7.5 will be 1000 will be your this thing algebra difference. So here also we need to provide vertical curve since it is more than 4 ohm per meter. Okay. So coming to deflection angle, how it is worked out here. Again here steeper, this is steeper gradient angle minus flat gradient angle. So here theta 2 minus theta 1 minus theta 2. Theta will be here. Okay. Same thing you can do it. Total angle will be the theta 1 minus this angle will give you the theta. Okay. That's what. So this is the way you have to do it. And coming to the other situation, sag, that means a steep up gradient followed by a flat up gradient. Okay, sag. Like that other situation, the flat down gradient followed by a steep down gradient. Both the cases we used to have this sag. So here also the deflection angle and the algebraic difference we'll see here. Here again upgrading we have to take positive only. So 1 by 400 we have to come this way, towards direction. 1 by 400 minus 1 by 100. So minus 3 by 400 will get minus 7.5 divided by 1000. So minus means that is normally sag. So here 7.5 mm per meter is more than 4 mm per meter. That's we need to provide vertical curve here. Coming to the deflection angle here again same thing, here theta equal to theta 2 minus theta 1. Okay, total theta 2 minus this angle will give you the this deflection angle, theta equal to theta 2 minus 2. That's what we made here. Like that here other situation, direction is this way. Here it is steep down gradient, then flat down gradient. Here also we can work it out the algebraic difference. Here since it is a down gradient, we are giving the negative sign here, difference is one minus sign, then minus of 1 by 400 we got minus 3 by 400, that's equal to minus 1.5 divided by 1000. Here same thing, 7.5 mm per meter, so it's more than 4 mm, then we need to provide vertical curve. Coming to deflection angle, the same way we have to do it. Okay, this theta 1 minus theta 2 is theta, the steeper gradient angle minus the flat gradient angle. Okay, okay, so I made this way. So this is the way we have to do it in another situation. Okay, this I want to explain you because okay, the normal situation there in the previous case worked out example. The other 4 type of situation we get, and for that you have to do like this. Okay, this is something about it. Okay, and finally using AutoCAD also it is possible we can do it. Okay, so using the AutoCAD we can form the vertical curve. That means first drawing the lines, 2 lines, that is up gradient lines, then down gradient lines. Then after that we have to draw a circle, okay, connecting tangentially. Then from there taking the measurement when the chainage is set 1000 and RL is 100. From here taking the measurement we will be able to get the chainage and RL of x and y axis. Okay, taking the measurement we can fix this chainage on RL and like this chainage and RL, and subsequently dividing the curve. Okay, Necker interval. Okay, selecting the lowest point. Okay, forming a one baseline. From there we can measure the offset, and after that we can get the RLs of the points which are on the curve. From base level to the offset, measuring the offset, adding this one, you will get. Just partly we do drawing and partly we do some calculation. This is one way, but realistic way also we can do it. Normally we'll have the AutoCAD drawing also will be there, profile drawing. There at that point you want to introduce vertical curve, and straight away we can, between the 2 lines you can introduce the curvature. Okay, then there also you can straight away take the levels, select equal interval, you can get the coordinates. Okay, levels possible, x and y. That is also possible. That way. That will be the realistic actually. Anyway, I will see on both. Okay, in the first method, you see, you draw the 2 lines, one in 100 rising gradient line and one in 200 falling gradient. That means that to 100 unit, 1 meter rise here. Then after drawing this line, we are drawing in a red line. Okay, giving the red color to that. And at the end of or at end of selecting a point, or at the end of the line you have to draw the line that is for falling 200 unit 1 unit fall. Okay, that we are drawing in green color. Okay, so after making these 2 lines, in between you have to draw the circle. That means connecting these 2 lines tangentially. Okay, so for that we have the option here. We can go to the circle here, tangent radius you can choose, and between then selecting the first line and selecting the second line, then it will ask you the radius, how much radius you have to provide. That radius you have to enter, then press enter, then the circle will form. So you are giving the color of yellow for the circle. If you just see, it will be tangentially connected, now joined with the two lines. So highlighting the look at in the points, tangent points, okay, both points. So you can get the change in RL of this point. You have to do some manually, you have to do the measurement. Okay? From here, dimensions you can take, this distance you can take, and this peak to this point, tangent point, y-axis distance, that distance you have to take. And from this we can get the change and RL of this point. Similarly, this also we can do it. This already it is given 1000 and 100 is they given the problem that we are fixing here, and from here we are reducing. So measuring we'll get the 30 meter automatically here. So then change accordingly will get, and level difference also we can get from peak to the tangent point 2. Here it is only 200, it is the 0.15 is coming. So by measurement you have to do, and from there we can get the change RL of this point. And after that, we have to select the point, the tangent point, which is lower. The lower one is this side, 99.7, here 99.985. So for the lower point, we have to, from here we have to draw a base datum line. That we are drawing a setting in ortho. We have to draw the line that we are drawing in a magenta color. So that line having the RL of 99.7 from the entire distance. Okay, that will represent the RL of 99.7. Then that 2 points between two tangent points. Okay, so we have to equally divide the part. You have to fix the distance. Suppose here 1660 meter. So 6 parts we are dividing 6. Okay, then every 10 meter interval we are marking station here. For each station we are measuring the offset of much with reference to this datum line. Here 99.7 then yellow color is our curvature, magenta color is, this is your baseline. So measurement we are getting here offset is 0.0875, here 0.15, here 0.1875. That is between the magenta color, that is baseline, and the arc, the point which is on the circle, which is on the arc, which is on the curve. Okay, that measurement we take for every station. So that will be your offset with reference to your datum line. Datum line level 99.7. Adding this offset, we will get the RL of each points. Okay, RL of each point which are on the curve. Okay, change of course because 10 meter interval only we are fixing the station. That is why 970 means 980, 990, 1000, 1010, 1020 and 1030, like that. Okay, that is possible. This is one way we do. It is only partly we do some drawing, partly we are doing some calculation. But realistic means it will be a little different. Realistic, normally we have some AutoCAD drawing, profile drawing will be there. And wherever there is a change of gradient takes place, and you can introduce an arc like this. So, okay, then straight away we can take the measurement, not measurement, directly we can take the coordinates. From that will give you a change in RL. Okay, that is also possible, and that also we can do it here, but that actual drawing I don't know, but anyway I am drawing this way. Let us take the problem they given 1000, chain is 1000 and RL is 100. Okay, so I am just giving the level from 0. This is the x-axis, y-axis. Okay, with reference to this origin I am giving a 1000. Okay, chain edge and 100 y-axis, that is the level. So I am fixing the apex point. From here, we are drawing a line. This side, 100 Okay, falling. This side 1 in 200 falling. That means rising 1 in 100 and 1 in 200 falling here. So from the apex point I am drawing this two line. For your understanding purpose I am doing. But normally you will have some profile drawing, some line will be there. In between you can draw the circle and provide what is there. Okay. So but here I am doing this way for your understanding. Okay. So once fixed on drawing the two lines, two upgrading line and downgrading line, and after that in between you can draw the circle, like is choosing this option, choosing this circle option, tangent radius, selecting this two line, after that selecting this one and selecting this line and this line, and will ask this one radius will ask, then entering the radius, then press enter, you will clicking this one and you will have circle formation that will tangentially connect both lines. Okay, once you form the curve, and what you do, you can just highlight this point, tangent point you can highlight. Okay, you will be able to locate it. That, but you have to straight away you have to take the chainage and RL of the points which are on the curve. Then again what you do, so between the two tangent you have to do some marking, station marking, 10 meter and some, you can make some vertical line, so that providing a line at some offset, by offset you can mark some station. Okay, so AutoCAD, those who know will be able to do it. Then after the marking the stations at every 10 meter interval, we have to set the point on the station. How to set the points on the station? Then you have to use the utility, select point style, and a lot of options are there. I'm choosing this one, size I'm shifting to 1. I'm choosing this one, set size in absolute units, and click OK. And clicking somewhere in place, and simply put some point and enter. Okay, so this is created now. So now created. So then it should be some layer also, proper value set. I'm giving coordinates, coordinate set. Okay. Okay, then I want to draw a leader connecting this point. Okay, connecting this point. Okay, then I want to add text also, single line. Okay, clicking this one, then clicking, then it's asking the rotation angle. I'm putting 0 here, enter. Okay, now the text box opens. Then clicking this one, right clicking, then I have to set the insert field. Okay, clicking this one, so that I want to connect text box with the object. So I'm choosing here object, and is asking object property. Which object? So this point, no, this is our object now. I'm selecting this object. So after that object, what you should do, what should be the property of the object? It should show the position. Okay, so clicking the position, and format should be in a decimal, and also I want only x and y coordinates. 3D means you can put this up. Now it is we are concerned about only 2D, so xy. I'm checking this one, and after that click OK. Okay, so now this has come. Okay, so now it shows the x and y coordinates of the point. That means x means in our case is chainage. This is our RL. Okay, because from origin only, where it refers from origin. We also put this level, our refers to 1010 also from origin I have put. Okay, so now this can okay. So now this is, you have made a point, and also we have connected with the text. Okay, that is, I'm connecting with the object showing the position of this point. Okay, now we can copy this, and wherever we want to show our this one x1 coordinate, that means chain agent oral, I can copy and move and fix that point. Okay, so it will show the location. That means x and y coordinates. That means the chain agent oral of the point. Okay, so already I made it here. Anyway, I want to remove this one. Let me remove this one. Okay, now yellow color is our curve. This is our mark, station mark. So this we are, if you want to set the point here, okay, what you do here, simply you just copy this one. Okay, so entire thing will copy, then we are moving to this. You are setting the point exactly here. That means this is your yellow line. Okay, there is a, so okay, now you have to keep this, the cross exactly here. Okay, then you have to move here. So move. So now we have keep this one, that's one, but the same thing only copied. Then you have to edit this one, you have to update. So clicking here, right clicking, edit. Again one more time, right click and you update field. Now, so this we got now. Now we got the oral of this one, oral, chainage and oral. It's 970, 990, 980. Then this is your oral, 7873, something is there. You can move anywhere here, this one, somewhere you can just, okay, just for clear this. Okay. So this is text, represents the position of this object, position of this point. Okay. So now like this, you can do copy this one and wherever we want to set. Then we have to do one time first edit, we have to do second time also when you are right clicking. We have to do this update field for doing it, and automatically the exact position, this will be updated. The position of the point will be updated, x and y coordinate. That means chain agent oral in our case. Okay, so like that we can directly this one can do it. Okay, we can compare the result also, what we have calculated, and we can compare the result also. Suppose here vertical this way, done, no, what we are cutting, okay, 99, 98, 99, 785, 783, 784, 785, yeah, something, 785, 7873, 7, okay, second 850, 980, 99 and 9000, 9000, then here 1020, okay, 8875, 8875, and 850, 85, that was the last time. So 899.7 at the commencing point tangent. Okay, okay, this is something about it. So we got this directly, we can do it like that. Okay, this is the other way of doing it. This is only the realistically we can do. Okay, okay, now let's see about the longitudinal track profiling of track. Okay, in railways. For this, in my website I am on application. So my website name is V.Thiagarajan.com. Okay, so clicking this one, you can put the website name. You can go to my site, and there are a lot of applications are available. Application for earthwork and for plain some low-lying area, some pond filling and all, and also for making a eroded embankment or a new forming a new embankment, and for longitudinal track surfacing. This one we are going to see. And apart from rear and setting IRSE design layout, something is there. Okay, so these are the applications available, and in our case now we are going to discuss about longitudinal surfacing. Okay, top tracking or longitudinal track profiling here. So using the option, okay, clicking that, you can go to this page, this form. Here you have to feed your data. That means existing levels of the track or road. You have to feed. Once you feed that, it will ask you the amount of lift, how much you can permit. Okay, amount of lowering, how much. That you have to give your further details. It will prompt you, and after that, if you are asking, it will give you the complete profile. What my profile it will give, and giving you the amount of lift or lowering, how much you have to do each and every point for getting the smooth level. It only smoothening. Okay. Actually, for this, you don't have data. First, for convenience sake, I have given sample input data here, and clicking this one, you can download. Okay. This this is our data. Okay, here the column is there. ID, of course, one column you put, just like a serial number you put, and for reference purpose it is not having any impact on that, but you have, for reference purpose, put on column where you want some kilometer or chainage, some reference you can make it here. And this is very important, station number. I start with 20, you can start with 1, 0, 1, 1, you can start with 1, no problem, because in between I have taken that is why here. So here every distance between the station, this is station number. So we are taking the longitudinal level for each station. What is the ERL, and we have to do some fly level, and we have to reduce and put here. Okay, so 1, 2, 3, 4, 5. 5 columns are there. This is only serial number, ID. 100 it is only for the reference. This one is station number. It's only station number. You can put 1, 2, 3 like that you can put, and between station, what is the interval, station interval. So every 15 meter you are taking the levels of the track or road, center of the track or road, so that it will give you the longitudinal profile. The existing profile will give. So 10 meter, 15 meter, 25 meter, 20 meter, you can, according to your choice, you make it. So closer interval will give you the perfect this one. So once you are feeding your URL of each station here, you have to do it only this format, exact format you have to follow that, or you have to download the copy this one, and in place of without changing the format, you enter your data here, complete data, and save it and import in this one. Okay, here this Excel form I have used 2003, that format I am using, and that format is old format, XLS format to use. Don't use XLSX. Okay, and don't use at present it will work only that Excel file, old Excel format only. Okay, this is the format. Now we can save here somewhere. Put it on desktop. Okay, and we have saved it in desktop, that one. Then now you have to import. So importing this, it just giving that means whatever I told, same thing it says. That means we normally use XLS, that 97 to 2003 power Excel format use for giving the input. Okay, that's what it says. So then after you have to choose the file. So now you have to choose the file where you have that. It's download is there, that also you can use. Now we have saved in the desktop also. No, so this one that you select in this one. Then it is that file has been selected now. It has come here now. Okay. Now after you have to click this button. This is the URL button, existing URL button we are clicking. Once we click this one, see, complete data has been imported here. Then after that, it's asking you minimum, maximum lift how much. So as far track is concerned, normally we will not lift much. Fine tuning only we used to do some 100 mm. Okay, we can give, and lowering if it is there we can give, otherwise we can leave it. When you are leaving, it will take a 0. Like that, when you are not feeding your maximum, now it will take 1000, assuming that one. Okay, this once you enter this one and you have to calculate, give a button. Okay, we have some other option also. It's obligatory point and so sometime we can't lift at certain location. Sometime in case of our railway track, so we cannot lift at level crossing much, because level crossing, there will be road surface, there is a car crossing between the road and the railway. So when we are lifting the track, that will affect the our road level. So that is why we used to minimize the lifting at the level crossing. That will become obligatory point. Like that, railway stations and also the lifting will be reduced, or sometime we won't allow any lifting, because the platform level you have to maintain. When you are lifting the track, what will happen? Platform level will come down. Height will be reduced. Thereby, it will infringe. Sometime it will give more gap between the step and the platform. That will affect the passengers who are boarding the train. Okay, so that is why there also we will restrict. Like that, sir, many obligatory points will be there coming across. Okay, and those locations normally we will give some 0 lift. Okay, so that we can here it will ask station number. If you are at, suppose put the station number, and 0 if you are putting, and add means it will add, and okay, that will see later. First with this we will work it out. Okay, calculate. So incorporated. So now maximum now lift we are given only 100 mm. So you will not get lift more than 1 mm. So it restricts the lift, and it is giving you the profiling. Okay. Then after that you can go for print also. This is your each and every station. What is the existing oral you have fed, and what is the proposed oral, and how much lift has to be done, or lift or making up. In case of road, normally we used to make up. And the level difference, gradient between the two stations, how much we got, like that. Okay. So unevenness, 3.6 meter chord, normally I just put how much it is unevenness. Okay, it will give you the perfectness of the proposed level. Okay. If you want to get the drawing, printout, exporting to Excel, you can click this one. It will export. Okay. Will export. So we put simply yes. So now we got it. So all complete level for it. This also Excel. You can export. Okay. Okay. This is about the printout. And coming to the drawing. Drawing you can get instant drawing you can get in the web page itself. Further this one, if you are not mentioning station, default of it will take from 0 station to last station, first station to last station. So okay, if you click show means it will give the drawing, but it is not visible because here 1:1. Normally now it's minute, we are completely plotting for a kilometer in kilometers, but whereas the amount of lift is very 100 mm. Compared to the horizontal, this one, and vertical scale is, it's very bigger, and you can't get, it's not visible. So that is why normally, only vertical scale only you are zooming. Suppose 30. Horizontal scale we don't touch anything. 30. That means for it is not a real scale, horizontally only vertical scale we are zooming to 30 times the existing. So we are able to see here. So like that, you only normally the undulation will not be like this, but only for visualizing purpose it has been exaggerated. Okay, so that this amount of perfectness lifting, and we have this amount of lifting, so that it will be uniform. Okay, so this is because we are given only hand arm lift, that is why we are getting this much. Suppose you are getting too much, it will connect this point, the amount of lift will be more. So that much we cannot afford, in a railway track and all, minimum lift will, otherwise it will lot of major, it will become major work. But it is all pyramids, it is all, it only, since it is showing like that, but whereas it is within the permissible limit of gradient and all. Okay. This is your instant drawing, you can see in the web page itself. And if you want to know our AutoCAD drawing also, you can click the AutoCAD drawing. You have to select the cell like that only, because 1 means you can't see the lifting, amount of lifting. So you can put some 100 and all, or you can go to custom and you can feed here whatever scale you want. According you can do trial, first trial 100 you put in, so see, even it is now you are not able to see with clearly, then you can increase the zoom. Okay. So now it is downloaded. Okay, now you put zoom Z and extend E, then you got it. Okay, so this is the green one is existing levels, and this red one is proposed levels. See here it takes care of some vertical curve also, wherever it is having it is smoothening, it will not be. Okay, here you see how much, but whereas it is giving smooth this one. So like that, it is giving all details also. Station number 20, our station starts with actually 20 started, and the distance 15-meter interval, and chainage. Okay, cumulative distance we are getting, and here ERL means existing oral green, how much, and proposed oral, that is in red. Okay, how much lift, each and every point lift, how much you see here. Here it is how much, almost it is 0. Okay, that's what 0 here. Maximum 100 here, you see here maximum 100 here. Okay, like that. If your 1-to-1 scale will not be getting, it will be RS, because it will be simply on line horizontal, both will be merging together, and we can't get this one. For purpose of visualizing only, I have put the scale in a zoom, vertical wise scale, some multiplying. Okay, so that you are able to get the actual difference. Okay, the amount of lift, much in each and every station. So this is the way we are getting it, and it is smoothening. Okay. Normally, in railways, whenever we do correction, during the maintenance, the undulations, after will be there always, because even though we are perfectly packing on time, it will not be lost long, and in course of service, it will be run down because of ballast, attrition, train traffic, and also weathering effect. Always the track will run down. So that is why periodically it used to be checked the levels, and it is to be corrected, the level to be corrected. And also not only that, and we do a lot of maintenance works. Sometime after some period, we used to do the cleaning of ballast cleaning. We used to do that, screening, deep screening of ballast. Once you do the deep screening of ballast, what you do, you will remove the entire ballast and screening the ballast, remove the muck, and put the fresh ballast inside. Okay, so when we are doing that job, automatically the complete track level will be disturbed. So during the downtime, after doing the screening, and we have to take levels, and perfect longitudinal profile should be set. Okay, and further also used to do some leveling levels. We used to take 5 levels in every 10-meter interval or 15-meter interval, 20-meter interval. After that, feeding the existing level, we are able to get the perfect, profiling, and we will be using this application. You can get the lift, amount of lift, how much required. Applying this lift, you will be able to get the proper profile. Okay, that is not all possible here. And also further I want to say about the obligatory point, no, that I am not told. Okay, suppose for example, suppose let us take this point here. This station number is 63, and the lift is 63. Station number 63, lift also I think 63. Suppose we don't want lift here, we want to give only zero lift because there is some obligatory point. Okay, we want to keep the level as it is without any lift. 63, and like that here also we'll have this point also. Some 85 is there, some 85, 100. Okay, 63 and 100 we will have the obligatory point, let us take. So in this we will give this option of obligatory point with these two stations is 300 and making the lift 0. So then let us see what will happen here. Then you would go to the obligatory point, obligatory point option, that panel. Then here we can give 63, let us give 0. Can we have to give add? So added, no. Of course, starting normally, it will start with 0 only lift. So 63. Then 100 again. Okay, we can another point also we are adding 100 also 0. Okay, 2 points we are giving as an obligatory point where we are restricting the lift of 0 to 0. Okay. So then again we go to calculate. So calculated, you can see here 63, 63 now it is 0, and also 100 also we got 0. Now we can see the drawing. You can go to even AutoCAD drawing itself. Okay. So again we can take same scale of 100. You can go here. So we can open it. Okay, so we can zoom and E. So we got it. So now let us see first 63 station. We can go to the station of 63. Here it is 0. Okay, here we got the 0 lift. That means here see this, since we are given an obligatory point, we are not permitting any lift here. 0 lift we have fixed. That is why we got 0 lift here. Like that 100 also here. This is 100 This 100 station also 0 lift, and we got here. So that option also available here. So you are able to smoothen the existing surface. So it will take care of some material also. And also in case of any obligatory points, we want to have no lift, that also possible. Or we can give some option also. So instead of 50 mm, we want to give only 20 mm, 20 mm we can feed. So the amount of lift also we can feed. So in that way the software is usable, and you will be able to get the smooth profiling, longitudinal track profiling. Okay. So in detail also I have given one more video. It is beginning I put, that also is there. You can go to my channel, you can search for longitudinal track profiling. There also you will get. I will do it right from start. Okay, why the profiling is required and all. Okay, normally we want to ensure the perfect level, so that the riding comfort will be there. If there is any undulation, there will be more vertical acceleration will be there. The comfortness will not be there. So that is why it is our responsibility, who is maintaining the the track, is supposed to ensure the longitudinal profiling of track without any undulations. So that for that periodically should be checked and longitudinal level to be corrected. Okay, this will conclude this video. I think it will be useful for you, and thank you very much, and we'll meet you all in the next video. Thank you.